We want to continue our discussion about hypothesis testing. In this particular one, we want to discuss a second method for performing hypothesis tests. The first method that we discussed was the critical value, where we needed to look up the critical value and compare. What we're looking at for this one is what we call the p-value method. The p-value tells exactly how unusual the test statistic is. It's the area underneath the curve. It's the probability. Once we calculate the test statistic, it's the probability that it is greater than or less than that value. The smaller the p-value, the stronger the evidence is against the null hypothesis. What it is if the p-value is less than alpha, we reject the null hypothesis. So if the p-value is smaller, we reject the null hypothesis. So let's look at this example. A test is made of the null hypothesis mu is equal to 50. I'm going to go ahead and write these down here so that we can see them comparatively, versus the alternative hypothesis mu is greater than 50. So when we look at this, we're talking about a right-tailed test. So we're looking at down here, okay? Z is equal to 2.60. Well, this is our test value. So that's like our ZT is equal to 2.60. And we need to find its p-value. So when we find its p-value, we go back over to our charts and we go up to our Z chart and we're looking for 2.60. Well, here's 2.60. It's a 0.9953. Our test is a right-tailed test. So the probability that Z is greater than, because it's a right-tailed test, 2.60. Remember, whenever it's on the right side, we had to subtract from 1. So 1 minus that value that we looked up, 0.9953, 0.9953, we get that our p-value is 0.0047. Think about normally. For an event to be unusual, it had to be less than 0.05. Is 0.0047 less than 0.05? Yes. So in this particular case, this p-value of a 0.0047 is very low, suggesting there is strong evidence to reject the null hypothesis. Anytime that we have an extremely low p-value, we're definitely going to reject. Again, if the p-value is less than the alpha, we will also reject. That was for a right-tailed test. Let's look at what happens whenever it's a two-tailed test. So in this case, our null hypothesis, mu is equal to 14, and our alternative hypothesis, mu is not equal to 14. So if we think about this, here's my drawing. Not equal to means that we shade both sides. And so when we shade both sides, that would mean that alpha divided by 2 would go into each side. So we divided our alpha by 2 in this case. Now, our test statistic is going to be a negative 2.31. So it's on the left side of our diagram. So what we do is we look up a negative 2.31. So we're looking up a negative 2.31, which would be a 0.0104. So our p-value is actually equal to a 0.0104 times 2, because we've got it on this side and we've got it on this side. Just like we divided the alpha by 2, we actually have to multiply the p-value by 2. And so our p-value is actually 0.0208. Anytime you're looking at a two-tailed test, you have to divide the alpha by 2, and then you have to multiply the p-value by 2. So again, since this is smaller than our 0.05, we would reject our null hypothesis in this particular case. So if p is less than or equal to alpha, we reject the null hypothesis. If p is greater than alpha, do not reject the null hypothesis. Okay, so let's look at a couple of examples and the steps for going through this. Now I'm going to skip the performing the steps because they're the exact same. Not sure what that was, I apologize. So they're the exact same as the other except for the p-value, and we're going to look at what happens. So let's look at an actual example. A national business magazine reports that the mean age of retirement for women executives is 61. A women's rights organization believes that this does not accurately depict the current trend in retirement. To test this, the group polled a simple random sample of 95. So I'm going to go ahead and start here. N is equal to 95. Recently retired women executives and found that they had a mean age at retirement of 61.5. So our sample mean was 61.5. Assuming the population standard deviation, so we have sigma, so that means that this is going to be a z test, is 2.5 years. Is there sufficient evidence to support the organization's belief at the 0.05 level of significance? So alpha is 0.05. Use the p-value method. So that means that we start out with believing that our mean is 61. So our null and alternative hypotheses are going to be compared to 61. Now, rereading this, a women's rights organization believes that this value does not accurately depict. Does it say that they believe it's less than or greater than? No, they just say that it's not equal to. So we have a not equal to. Okay, so our alpha is 0.05. Now, when I start to sketch the diagram of this, it's a two-tailed test, and I don't put the entire 0.05 in there. I put 0.05 divided by 2 is going to go in there. 0.05 divided by 2. This was a z, so whenever I look at, and I'm going to go scroll down to that table that we can use with the z, which is this one, and I'll erase what I have up here. So we're looking at a two-tailed test, and our alpha was 0.05. Now they have already taken into account the division of 2, so this is our critical value, positive and negative 1.96. So we have a positive and a negative 1.96. So I'm going to put a negative 1.96 here and a positive 1.96 over here. I'm going to calculate our test statistic. So our z sub t is going to be 61.5 minus 61 divided by 2.5 over the square root of 95. So 61.5 minus 61 is going to be 0.5. 2.5 divided by the square root of 95 is 0.2565. We divide this out. Our test statistic is a 1.95. So if I look at this 1.95 here, it is going to be slightly over here. But we want to find the p-value. So what we do, we have to be careful because this is a positive, correct? So that's going to be on the right side. So we're going to have to look at our p-value. We know that we're going to multiply it by 2 because it is a two-tailed test. But because this is a z that is positive, I'm automatically going to subtract whatever value I look up from 1 because it's more than half. So let's scroll back up to a 1.95. Erase what I've got here. 1.95, so 1.9 and 5 would be right here, 0.9744. Again, I need to subtract that from 1 because it's so far over there. So I'm going to subtract that 0.9544 from 1. So I get 2 times a 0.0256. So my p-value is 0.0512. Comparing the p-value of 0.0512 to the alpha of 0.05, you'll notice that this one is slightly larger. So my p-value is larger. It's not in the shaded region, so do not reject the null hypothesis. And then when we are talking about the conclusion, since we did not reject the null hypothesis, there is not sufficient evidence at the 0.05 level of significance to support the organization's claim. And so whenever we're looking at this, one thing I want you to note is that the p-value method and the critical value method, they should say the exact same thing, okay? Be very careful. Anytime that you calculate a z that is greater than 0, so it's a positive value, in order to find your p-value, you need to subtract it from 1. Then if it's a two-tailed test, we need to multiply it by 2. I want to look at one more example to help solidify the p-value method. This one says, according to the National Center for Health Statistics, the mean weight for an adult female in the U.S. is 164.7 pounds. So they're saying that the mean weight is. So that's our mu, 164.7 pounds. A group promoting healthier eating habits feels strongly that it has made an impact in one community by reducing the mean weight of women in the community to below the national average. So since we're reducing, is that going to be less than, greater than? Okay, it's going to be a less than. So we know that we have this, and we already know that it's going to be 164.7 pounds that we're looking at. A simple random sample of 39 women in this community has a mean weight of 161.8 pounds, assuming that the population standard deviation, so sigma, is equal to 5.6 pounds. Is there sufficient evidence at the 0.01 level of significance, 0.01 level of significance, to say that the mean weight of women in the community is less than 164.7 pounds? Use the p-value method. Okay, so we know that 0.01 is here. Now, since I have sigma, since I have the population standard deviation, I know that I'm using a z. So I'm going to go through here and scroll down. Anytime that I have a z, I'm going to look at this chart right here. And we were looking at a less than, so a left-tailed test, and our alpha was 0.01, so a negative 2.326. So negative 2.326. We draw our diagram, and it's left-tailed, so it's less than. In here is the entire alpha, 0.01. Critical value 2.326. Now we need to calculate our test statistic, ZT. That's going to be 161.8 minus 164.7 divided by 5.6 over the square root of 39. So 161.8 minus 164.7 is a negative 2.9. 5.6 divided by the square root of 39 is going to be approximately 0.8967. You'll notice that I'm not simplifying the denominator down to 2 decimals. I want to leave more decimals than that. I want to be as accurate as possible, so I want to keep as many values as I can there. So my test statistic is going to be negative 3.23. That's going to be somewhere way over here. Negative 3, let me get that erased. So that's going to be a negative 3.23. We need to look at the p-value. Now notice that this is on the left side, so whenever we look at our z-chart and we're looking at a negative 3.23, well, the negative is already going to be on the left side. So a negative 3.23, here is my p-value. I don't need to multiply it by 2 because it's strictly a left-tailed test, and I don't need to subtract it from 1 because it's already on the left side. So my p-value is a 0.0006. My alpha was a 0.01. Looking at this, the alpha is larger, so the p-value is less than, so we reject the null hypothesis. And you will notice that whether I use the critical value method, it is in the shaded region, so we do reject, or the p-value method, they both tell me to reject the null hypothesis. So our conclusion, there is sufficient evidence at the 0.01 level of significance to say that the mean weight of women in the community, and it might help if I actually put women instead of weight there, mean weight of women in the community is lower than 164.7 pounds. And how I did that particular conclusion, I knew that there would be sufficient evidence because we did reject the null hypothesis, and I just said this right here. So I'm going to say that there is sufficient evidence or there is not sufficient evidence to say all this. Okay? So we want to practice using the critical value method and the p-value method, and then let me know if you have any questions.